Hello everybody, welcome back to the shop and the F-14 Tomcat. Been a while since the last video. I've been kind of swamped with work, and for probably about the past 2.5, 3 weeks we've been packing up and moving. So as you can see, things aren't really packed up here because we already moved. We're now down here in the good old sunny state of Florida, and we'll be here for a while, I guess. You never really know. Anyway, got the new shop here kind of set up. A little smaller than the last one, but it'll make do. F-14 mold for the fuselage is still there. It's still primed, and it's ready for layups. I got all my stuff from RNG Composites in Germany. I got all the Airex and the carbon fiber and some layup tools and all that stuff. I got all that stuff in about a month ago. So I've got all the materials to do the fuselage and the rest of the, well, basically the entire airframe. I also got a couple machined samples for the horizontal stab pivots, the wing sweep pivot mechanism brackets, main landing gear rims and tire molds. So I got quotes on getting all that stuff machined up. Tried to keep it here in the US of A. Price wise, that's just not gonna happen. I wanted to do that, just kind of keep work here in the States, but the pricing was just astronomical. I'll get on into that a little bit more. The shop here, you can see it's all set up, fuselage mold, 4x8 table with the big white thing is it's a cutting mat that you see in like sign shops and whatnot. I got that one from, I think, a sign shop supply or something like that off the internet. It's about 150 bucks. That way it'll make cutting fabric all the fiberglass and carbon layers much easier with the roller cutter. You can see fiberglass here on the edge. It's wrapped up in a green shipping plastic. I haven't gotten around to unpacking that stuff. Take the tripod and whatnot over here. Today I just got done building this, which is basically just it's a fabric rack. It's about 100 bucks in materials, and about 65 of that's in PVC pipe. Basically it's just 1/2 inch MDF here on the sides, 2 foot by 2 foot, and then some 1x3s running vertically down here on the edge, or 2x3 actually, then a 1x3 under it, and then there's casters, some 1x3s here with basically I just took I believe it was a 1.5 inch hole saw and cut little half moons for the PVC pipe. Then the PVC pipe's 1.25 inch. Anything smaller than 1.25, and it sags too much. There's a roll, you can't see it, but there's a roll back here on the back on this second layer. That's 100 yards of 3-ounce crow's foot. That roll weighs about 25 pounds, and that 1.25 inch PVC doesn't really boil all that much. Another thing I did, there's 3 layers or 3 levels. You got 4, 4, and 4 rolls that you can hold, so it'll hold 12 rolls down here. And then this top part up here is elevated to where it's 6 inches above this cutting table. That way all you gotta do is just roll the cloth out, let it droop down on the table, put your template down, which I'll show you template material here in a bit, and run your rotary cutter around, and you're good to go. So the table will actually hold 13 rolls of fabric, and it's sized where you can go up to 65 inches in width across. Like I said, about 100 bucks. If you do a lot of woodwork, you probably got enough scrap material laying around to do it. And it's on casters, that way you can roll it up to the table, cut your stuff, and roll it back out of the way. Another thing I did is I grabbed some more PVC pipe, and let me move the camera around. You can see I got some shelves over here, and I took some PVC pipe, capped the ends of it off, and then I just ran this those ACP Composites quick locks in there, That way they're there and out of the way and easily found. Shelf with molds and stuff on it. Pretty much all those molds are prepped and ready for layups. This top shelf has got horizontal stabs, rudder, and a canopy frame mold that I got to redo. And then there's some flat molds and stuff. The big box here with the yellow stuff inside of it, that's just barely off camera. What that is some 60 thousandths plastic. I found this stuff on eBay. What I'm going to do is I'm actually going to use this really thick stuff, and I'm going to use this for reusable templates for all the foam layers. So basically I'll take a piece of foam, like a weenie skin or whatever, and I'll use that to get the size that I need for the layup, and then I'll transfer that template to this stuff, cut this out, and then anytime I need a piece of foam, I'll just pull that plastic template out, stick it on the foam, and then go around it with a box cutter or whatever, and cut it to shape. I've got some more stuff of this. It's 20 thousandths. It's white instead of yellow, and I'm going to use the white stuff for all the fiberglass and the carbon fiber layers. And the two colors I'll tell you: yellow thick stuff for foam, the white stuff's for everything else. And then the white you can get on there with a Sharpie marker, and you can write carbon fiber, and you can put arrows for whatever direction you want to put the weave direction, if you want it on the bias or straight or whatever. So that's basically the new shop and where I'm at with that stuff. Let me take this camera off the tripod. I'm going to show you guys something that's kind of surprising. When it comes to carbon fiber, everybody that's shopped for it knows this stuff is god awful expensive. This stuff here it's a 3K cloth, but it's not quite a full 6 ounces. It's like 4 or something like that. 160 grams per square meter, whatever that is. And it's a twill. It's a 2x2 twill. It's about 35 inches wide, and it's a 5-meter roll, so it's about 5 yards or so. This stuff from the US is about 90 bucks a yard for the same width. This 5-meter roll from Germany was 150 bucks. So you're getting basically 4 times more material for the same price as you were to get it here in the US. To ship this roll is probably like 15-20 bucks from Germany. And these guys, they use FedEx Economy. I ordered this carbon fiber, and well, you can see this Airex box here, and then there are these 2 boxes of Airex here that are about 2 foot wide and darn near 7 foot long. All of that, and then another big box from Germany. I ordered this stuff I paid for it on a Sunday evening, and it showed up the same Thursday, the same week Thursday. So I mean, it was like literally 4 days for it to show up from Germany. And it was $120 shipping for all that stuff. So the shipping was actually very reasonable for Germany, and it got here extremely quick. I expected at least 2 weeks, and when it showed up at 4 days, I was surprised, to say the least. So all that stuff came from Germany. Carbon fiber, buy it from Germany. That's an aero grade carbon fiber. So it's one of the more expensive ones they had for the lighter weight stuff. But even so, it's cheaper than buying it here in the US from ACP Composites or Solar Composites or the Carbon Source or whatever. Don't know why, because the stuff is made here in the US. So it's cheaper to make it in the US, ship it to Germany, then ship it back to the US. Whatever. As long as it saves a little bit of money, who really cares? Some other things I got from the guys there in RNG Composites. Not this. That came from ACP. They had these little maxi roller kits or whatever. I think this big one was $10, and it's a 4-inch roller. And you see it does come with a little foam thing there, and this cute little reusable paint tray. But they also had the mini one, which I think is a 2-inch roller, and it comes with 2 rollers. I think this one was like $5 or $6. Got those for doing the fuselage layups really nice and quick. Then they have these refills. If you try and find stuff like this here in the US, you can't really find foam ones for a decent price. They've got phenolic ones, but one phenolic refill for a 2-inch or a 3-inch roller is like $4. This whole pack of, oh, let's see, there's 20 in here. I'm sorry, this is a big one, so there's a pack of 10 and 10, and then the little refill, which is here, has 20. So I mean, this whole pack of 10, I think for the big ones was around $10, and the little one was about $10. So I mean, you're getting basically one for $1. Again, when it comes to this stuff, it's cheaper to buy it from Germany and just have it shipped back over here. Don't know why, but it is. ACP Composites order. Like I said, I got those quick lock seals over there in the tubes. I got this nylon vacuum bag tubing. This is 18-inch wide. You see I got a whole bunch of it. This is for like just oddball stuff like, I don't know, rudder halves or whatever. I can fit 18 inches in. Flaps are probably gonna go in there. I got some 60-inch wide stuff up here, another 15 yards of that. And I got some more perforated plastic. I got, well, let me get my son's wagon out of the way. You come in here, my goodie cabinet, as I call it. Breather cloth. People have asked me kind of what I use. That's what I use. This stuff's from Walmart. This whole thing, which is about, it's 110 inches, about 110 inches, so whatever that is, I think it's about 2 or 3 square yards. It's like $6. 1 yard of this stuff, 60 inches wide from ACP or whatever, is like $6. So it ends up being about the same price wise, but got that. Lots of micro balloons and cotton flock, more pill ply here. I got this stretch on vacuum bagging stuff. This stuff's kind of expensive. 5 yards I think was $50. I think it was like right around $6 or $8 a yard, something like that. I got this just to kind of play around with. A lot of people say it leaks because it stretches so much, but I got it. And I got this carbon unidirectional stuff just to kind of play around with. I wanted to see how well this would work on the wing. Bunch of vacuum bag tape, whole bunch of epoxy, and then over here I got more epoxy, and then more epoxy. I got about, oh, that's got about 1.5 gallons, 2 gallons in it. That's a full 5 gallons. And then there's another, I think, 2 gallons of epoxy in there. So I got about 10 gallons of epoxy. Plenty of stuff floating around. All that stuff. And yeah, brushes, gloves, and everything at the yin yang got stocked up before we moved, because I'm ready to get some work done. Now, let's get this camera back up here on the tripod. As you guys can see, my wife has infiltrated my garage with a dryer. So, now, those samples I was talking about, they, like I said, I wanted to keep this stuff in the US, but pricing just really doesn't make it cost effective to do. For instance, I've got this, oh, as you can see right here, so I get y'all zoomed in here. This is the facing, the main face or whatever of the main rim for a D model Tomcat. This is a late model rim. There was a difference for the earlier ones. These samples came from a company in China. Before you start screaming, oh my god, China, what's the quality going to be like? I mean, you can see the machine work on this is exceptional, and this is just a sample. So I'm sure it could possibly be better, just because it was a sample and they're trying to get business. But as far as the metal quality and all, it comes with a certificate of origin for where the actual metal came from, so I can make sure it meets the specs that I want. Detail wise, I mean, you can see every bit of detail in the CAD model is in this thing. I mean, even the little holes here, the larger holes have the little fillets around them. The center board here is counterboard for a ball bearing. It's got the nice little fillet there. The radius is here along the rim. I mean, everything, all the measurements and all I took off of an actual F14 rim is on this faceplate. There is a kind of an axle cover that goes over this, and on the real one that holds the anti-skid sensor. That's actually going to be a machined portion of the axle itself. So it'll be there, it's just not going to be part of the rim. It's going to be the axle itself, and it'll just cover up, and that actually will help hold the ball bearing. There won't be a bolt or anything. The axle will actually go through, sandwich into the ball bearing here, and then the back half, which the 3D printed part will represent for now, will have another ball bearing, and then the brake assembly, and then of course the landing gear strut, and that'll all get held in place by a I think they call it a pin bolt. It's just a bolt. It's got a really it's got a smooth part, and then up against the head there's a threaded part that actually thread into the strut and the axle, and then the pin will kind of go into the strut as well. But, I mean, just give you an idea of the size of this thing. If I can find my tape measure, here we go. There's the diameter of it, and we're just under 3 inches, and just under 1 3, well, about 1.5 inches, right at 1.5 inches. Pricing, what I was saying, this part from this company in China is well under $100. This particular part from a company here in the US was going to be closer to $1,000 for one. Yeah, $1,000 for that, just one of them. And they said they could get it down to about $100 a piece if I bought 1,000 of them. And honestly, I don't think I need 1,000 of them. So as long as this Chinese company can keep up with the quality and the detail wise, and keep with the certificate of origin for the materials, I have no regrets actually using them for these machine components. So that's one of them that I received. The other one is this big hunk of aluminum. When I keep saying the big carry through spar and the fuselage carbon carry through spar and the hunk of aluminum, this is what I mean. Basically this face here with the bolts, 5 bolts here, there's going to be a solid piece of, well, not quite solid, there's going to be a molded piece of carbon fiber that's going to go on this whole outside dimension, and then the top skin is going to make up a portion of this here. And then this is going to get bolted to that carbon face, and then this carbon face is going to be kind of like an open U, with the top of the box being the fuselage skin, goes all the way across the fuselage. And then on the other side you'll have the exact same thing, just opposite, and then the other one will bolt to here. So you're going to have 2 of these at each other ends, and then they're going to be sitting there forcing against the fuselage, and the whole fuselage becomes part of this whole center box structure. If the CAD model works out and the molding portion works out like it should, if you ever crash this airplane, this whole center wing spar structure will still be left. I fully expect it to be extremely overbuilt, but again, I've said it numerous times, this is the one section of the airplane, this whole pivot mechanism to the wing panel across the carry through spar to the other side. That's one area of the airplane that I don't care if I add an extra pound or so to, if it makes it stronger to where you can pull 15 G's instead of 10 G's while you're flying, I'm perfectly happy with that. Back to this part, this is, again, it's just a giant piece of aluminum, and you can see here where there's a kind of a ridge line where the cutting bit came in. This one's slightly undersized on this interior dimension. I didn't give them any sizing criteria as far as what they could go off of nominal. I'm gonna have to give them one for this because again it's a little undersized where it actually won't go over it's a really nice snug fit to the wing panel when it should be a little looser, so you can have a little bit of bearing place so you can preload the bearings for the pivot. But 1/4 inch thick here, I mean it's a big hunky piece of aluminum. It probably weighs, I don't know, 8 ounces or so. I haven't weighed it. Kind of scared to be honest. It's not really that heavy, but it's good. I'd say the pair of them is about half a pound, maybe a little more, but no more than a pound. But again, that's the big, this is like the hefty Mama Jama. This is the weak link of the whole design, this whole assembly right here with the interior wing panel and all. So as long as that comes out and meets my stress criteria, I'll be perfectly happy. The prototype wing panel layup I did, I've still got that wing. I haven't messed with anything of it. I did some research on the Flyeagle Jet F14, and their wing panels come in around 6 pounds or so. That was the pre-honeycomb version. I'm not really interested in what the honeycomb version does because, well, I have my reasons. I won't get into the whole dramatization of that. Anyway, 6 pounds for the Flyeagle Jet F14 panel wings, but that's the wings, flaps, and spoilers and everything. My wing by itself, not including the flaps or the spoilers, is 3 pounds. I'm pretty sure that is severely overbuilt. Again, I fully plan to stress test that wing panel before I actually try and fly anything. And this is a key part of stressing that wing panel, because I'm not going to sit there and bolt a wing to a table or whatever by the wing root, or put a carbon fiber tube across a bench and then weigh the panel and watch the carbon fiber tube break. And in my opinion, the only way you can accurately and realistically stress test an airplane, especially a wing panel, is if you stress test it exactly like it's gonna see the stresses transferred to it. In my case, bolting the wing panel into this with the bearings, bolting this to a fairly solid structure, in this case it would be that 4x8 foot table, and then start loading the wing down with sandbags. I hope and I expect that wing to hold 250 pounds, no problem. That should give you about a 10G loading at 55 pounds or so. If you consider the fuselage produces about 20% of the lift of the airplane. And I've been told it produces upwards of 40% depending, but 20% is a good low number for me. So if it holds 250 pounds, I'll be happy. If it does that, I'll probably stop the loading at that point, just so I can use that wing panel to build up the slat and the spoiler plugs for that right side. And then once I get those plugs built up and molded and everything, then I'll go back and I will stress test that wing to failure. I expect it to hold about 350 to 400 pounds before it even starts to break. Again, I'm pretty sure that wing panel is extremely overbuilt. If that's the case, fine. If it's underbuilt, we'll figure out where it fails and then we'll adjust from there. That's the whole name of the game. I'm in no hurry to get this done. It's been almost 6 years now. What's another 2 or 3? If it's done right, I don't have to worry about a structural failure on the prototypes made in flight or anything. So that's basically where I have been for the past week, and what I have been doing, and where I am gonna go. I gotta wait for a couple of those machine parts to come in. I think I'm gonna place an order for a full set of that stuff, just to have it so I can get this fuselage molded and then the internal structure figured out. Still trying to figure out what I'm gonna do about landing gear. I thought I had that issue figured out, but needless to say, that's not quite where I'm at. It might be a thing where I just have a set of 3D printed gear done so I can get the internal structure done, and then from that point on, then I start looking for landing gear and determining what I'm gonna do. The one guy I thought I was gonna do is me and him are just a little too far apart on pricing for one set. We're about at the right pricing if I buy 5, but I can't justify buying 5 when I don't even have one airplane that's flying yet. So anyways, that's where I'm at. I'll pop in the video camera and I'll make up some more videos as I start progressing more work. Hopefully this weekend I'll get that aft portion of the top of this F14 mold taken off, and I'm gonna start from that point prepping glass layers and foam layers. That way I can start making templates and getting that rear fuselage section laid up. And then from there on, the rest should be the easy part. Well, other than the top part up here, the whole bottom part should be easy. But that's where I am. Got all the materials, got parts, lack of money. My bank account's in intensive care unit right now because it's on life support for sure, especially with this move. But anyways, you guys and dogs, you ladies and gentlemen, have a great week, and we'll see you back here in the shop.